Okay, we're going to start the law of sines today and maybe the law of cosines. Y'all ready to start? All right, positive, yes. Law of sines. We use the law of sines and the law of cosines to solve oblique triangles. So, to solve oblique triangles, which are triangles that have no right angles. Okay, so that's what we use the law of sines and cosines for. So, today we're going to look at, and there are 4 cases where we have an oblique triangle. We use the law of sines to solve the first 2 cases. So the first 2 cases that we're going to use to solve the law, to solve oblique triangles with the law of sines will be when we have angle, angle, side. So if given a triangle, we know we have 3 angles, 3 sides. If we're given 2 angles and a side, or angle, side, angle. So 2 angles with an included side. That's the first situation. We'll use the law of sines. The second situation is if we're given side, side, angle. So 2 sides with an angle opposite. So we're going to look at these 2 situations in dealing with the law of sines. Okay? So let's define the law of sines. So let's look at what the law of sines is. If A, B, C is a triangle, with sides little a, little b, little c. So angles here are represented by capital letters. The side, the length of the sides are represented by lowercase letters. And what we may have is a situation looking like this, where here this is my angle A, the side opposite is my little side A. My angle B, the side opposite is my little b. The angle C, the side opposite is my little c. Okay? So here we look at A. A here is an acute angle. Do you remember what acute is? Okay, yes, less than 90 degrees. Or we may have a triangle looking like this, where this is A. Here, A is what? Obtuse. What does that mean? Greater than 90. Okay? And when we have this law of sines, we have to drop this vertical so that we can form a right angle. Okay? Drop that vertical. This represents height, and this vertical represents height, the height of that triangle. But anyway, if we're in these 2 situations, then the following is the law of sines. We have A, the side A over the side of angle A equals B, sine of the angle B, C over sine C. We can use that form, or we can use an alternative form, sine A over little a, sine B over little b, sine C over big C. Either one of those, okay? They're both the law of sines. We just have 2 forms depending upon what you want in the numerator denominator. Yes?
So each triangle, you have to somehow make it 90 degrees, whether 90-degree angle, whether it is you're drawing little dotted lines. You have to draw extra, or you just draw?
You're not really going to be drawing.
You're not drawing, but like
what we're
dotted lines.
Yeah, but what essentially we're going to be doing is they're going to give us in the first situation 2 angles on a side, and we'll have to figure out the other components to the triangle, which means what? 2 more sides and 1 more angle. Okay? So with this first situation, it's not going to be that difficult. The second situation will be kind of sticky. And there we're going to have to find H. But we'll have a formula for finding H. Not that you'll have to figure it out from a drawing. Okay? So, we can use either one of these equations depending upon what you want to find. I mean, they're the same basically for the law of sines. So the first example we're going to do will be when we're in this first case. And this is the easier case in dealing with law of sines. So we want to use the following information to solve the triangle. Okay? First example. And they give us this triangle with certain components. Okay? They give us that this is angle A, little a, angle B, and they tell us that angle B is 40 degrees. With the law of sines and cosines, you're going to have to change your calculator to degree mode. Okay? We're dealing with degrees here. Angle C is 105 degrees, and side C is 20. So they give us what? Two angles and a side. So we have to find the other angle and what? The other two sides by using the law of the law of sines. Now, first of all, how many degrees are there in any triangle? 180 degrees. So since we know two of the angles, we can find the other angle easily, right? A would be 180 minus 105 minus 40 degrees. So when we do that off the bat, we can get that A is 35 degrees, okay? So in this situation where we're given two angles and a side, we can easily find the other angle by subtracting those two from what? 180 degrees, okay? Now I have to go about finding side A and side B. Now notice how my formulas are set up. They're set up so that I have sine angle C over little c. I was given, yes, angle C and little c, so I know I'm going to use a portion of this formula dealing with that, okay? And I'm going to use, because I know A and B, I'm going to pair this sine C over C up with, let's say, sine A over A to find little a, because I know big A, so I can find little a. So when I'm finding little a, I can use that, and it doesn't matter which form I use. Well, it really does. I mean, it doesn't matter, but I'm finding little a, so I may want to use this form because little a is already in the numerator, okay? So I can say little a over sine A is little c over sine C. And I can find little a because I can multiply both sides by what? Sine big A. And I know big A I found to be what? 35 degrees. Little c, 20 units. And sine of big C, 105 degrees. And I can plug that into my calculator, making sure that my calculator is in what? Degree mode now, okay? And if I put all that in there, I'll get that little a. And we're gonna have to approximate. So get what? Get two places after the decimal, approximate to the hundredths place. I have 11.88. Okay? So we're gonna have to do some approximating here. We're not gonna be getting exact answers. Okay?
Is that degrees or
no? No, little a is length.
Oh, yeah.
And it doesn't give us any units. Okay?
So can we use either or?
Yes, you can use either or. Doesn't matter. I need to find little b. So when I find little b, I now need to pair up one of the two. It doesn't matter. I can say little b over sine b, and I can either use A or C here. It does not matter. But I may want to use C because that was given to me, okay? So use little c over sine C. So B is sine B. What was B? 40 degrees times C, 20 over sine C, 105 degrees. Put that in my calculator in degree mode, and I get 13.31. And that's whatever units that we have there. Are y'all getting this on your calculators? Okay, should be. So I have found all the components up to my triangle. I have found, or I have my 3 angles, and I have my what? 3 sides. So y'all, that's the first case of law of sines, given 2 angles and a side. The next case is the ambiguous case that she was talking about, and there we have so many possibilities, okay? So we're going to really spend time going in depth with that case, okay? Now, let's talk about this ambiguous case. Case 2. This was case number 1. This was our, what? Angle, angle, side. Now let's look at case number 2. And this is where we're going to have 2 sides and 1 angle. Now, the reason why we have such a hard time here, this is more complicated, is because we're going to have to find 2 angles, okay? If we're given 2 angles, we can pretty much find the other one. But if we're only given 1 angle, then sometimes we may have the case where we can't find a triangle to find the other 2 angles. So we may have a case where, hey, I can do 2 angles, because we know that the sine values repeat depending upon which quadrant you're in. Right? So it depends on the angle that you're given, if you're given an obtuse angle or an acute angle, whether you can find a triangle at all. Okay? So, and this case is confusing. So let's try to listen and to see if we can break this down like it needs to be broken down. Okay. Okay, we want to consider a triangle in which you are given little a, little b, and some angle a. Okay? So they're just using as a standard for these cases that we're about to discuss that you're given big A, and little b. Now, in some of the problems that you may see in practice, they may give you B, little b, and C. Okay? But, and it's very confusing. I hate that some authors do this, but you're going to have to rename whatever angle you're given, you need to call it A. Okay? So that you can figure these cases out, even though it may say B or C. That's going to be confusing. I know. That's why I need to write a math book, don't I? I need to write a math book. Need to write one, because they do just crazy things here when they should label them A, B, C, instead of saying, well, I'm giving you angle C, but the angle that's given to us, we need to think in our heads, will be A. So that angle and that corresponding side will be given and another one, another side. We need to think in our heads, A, big A, little a, and little b. Even though they may give us C, big C, little c, and little a. I know. Okay, so the first situation we're going to look at. This A that we're given may be obtuse or acute. So we need to break that case down into 2 cases. So let's look if A is obtuse. Which means what? Bigger than 90 degrees. So if A is obtuse, then there are 2 cases, okay? If this little a is less than or equal to little b, then this means that no triangle is possible. That means that, hey, we can't draw a triangle like that, okay? And there are some instances where we cannot draw the triangle fitting this, okay? The second case is if A is greater than B, then that means we have 1 possible triangle. Now let's talk about what A is bigger than B mean. What does that mean? we know that our larger angle, right, the side opposite of larger angle will be the longest side, okay? So there is a comparison there, okay? The smallest angle, the side opposite that smallest angle will be the smaller side, okay? So if A is bigger than B, then there's one triangle possible. So if A is obtuse, if it's bigger than 90, we're in those situations. We need to compare A and B, and they're given, okay? Now, if A is acute, which is less than 90 degrees, then we have three situations. And this is where that H comes into play. And we need to define what H is, and we'll define it here. H is B sine A, okay? The height of that triangle is going to be B sine A. That's H. So in this acute case, they bring in this height. So the first situation, if A is less than H, then no triangle is possible. Okay? Number two, if A equals H, or if A is greater than B, then we have one possible triangle. And number three.
Wait, is that when you have or A, is that B or H?
B. B. So now if H is less than A and A is less than B, then this means that we have two possible triangles. Two possible triangles. Now we're going to do an example where we have one possible triangle, no triangles, and two possible triangles. Okay? Now you're going to have to figure out, you know, this A that's given, is it obtuse or is it acute, and then do these things accordingly so you can know how many triangles you're supposed to get. Okay? Y'all ready to do some examples? Have we written all that down? Almost. We'll give you a minute because we really don't want to leave you behind here. Okay. The first example. The directions, the same as before. Use this information to solve the triangle. So get the other sides, the other angles. So the first example. They give us that A, and I need to make a note before we start this example. No, let's go ahead and start the example. We're given that A is 60 degrees, little a is 9, and C is 10. Now, what's given here? It says we're given little a, little b, and what? Big A. So, just as a side, we'll go out here to the side and we'll relabel this stuff to see which situation we're in, and then we'll come back to the problem and use the variables that are given. So yes, big A is already labeled as 60 degrees, little a is 9, but this problem says we have what? B, doesn't it? So B here would be 10, and we need to use that to figure out which situation we're in. So, is A acute or is it obtuse? Acute. So we're going to be in one of these three situations, which means I need to figure out what? H, don't I? So what's H? H is B sine A, and we're inside our little box now, so we've changed our variables, okay? So H is going to be 10 sine 60 degrees. So what is H? 8.66. So, which situation are we in? A, which is 9, is what? Let's see, we're in the third case where H is 8.66. That's less than our 9 and less than our B, which is 10. Because here, A is not less than H. A is not equal to H. A is not bigger than B. So we're in situation number 3 where we have what? 2 triangles. So you need to change your variables to figure out how many triangles you're looking for. Okay? So we have 2 triangles. Because we have that H is less than A is less than B, which is this situation, because we're in the acute state. So we have 2 triangles, okay? So that means that if I go, now, this tells me how many triangles I have, so now I go back out this box to the original problem, and my variables are labeled as they were, okay? Now, because they're giving me big A and little c, what do I need to find next? Big C, right? I need to find my big C, so what that means is that I'm going to have 2 angles that I can get when I do these calculations. So, I have the fact that sine C over little c equals sine A over little a, which means that what? Sine C is little c times sine A, and we should be substituting these in. What's little c? 10?
Oh, are you like cross multiplying or something? That's your little equation, and then you plug in what you have, and then you cross multiply.
We multiply both sides by c to get rid of it over here so we can have sine C on one side, because we're trying to find the angle C.
So you're like skipping a little step there.
Yeah, we're skipping a little step.
That's where I'm getting confused. Go ahead.
Okay.
I have to do all the little bitty stuff.
You have to do a little bit of steps. We'll do a little bit of steps for this first example, but y'all, we ought to be at a stage and we don't have to do these little bitty steps. We can multiply both sides by what? Little c. This cancels. So sine C is what? Little c, which is 10. Sine A, which is sine 60 degrees, all over little a, which is 9. So when we do all that, we get that sine C is what? 0.9623. Now, this is where it comes in, because if we think about sine, sine is positive in where? Quadrant 1 and quadrant 2, right? In sine positive in quadrant 1 and quadrant 2, which means that gives me my 2 possibilities. I can find an angle in quadrant 1 that has sine value 0.9623, and I can find a sine or an angle in quadrant 2 that has sine value the same thing. So if you plug this in your calculator, do inverse sine of 0.9623 and see what you get. What do you get? Inverse sine. That's how we'll find that angle. Sine to the negative first power should be second function sine, or on these big calculators. Okay, so I have 74.21, but that's okay. So this is my what? My first quadrant angle that has sine value. Okay?
So you put in the opposite of sine?
Not the opposite, the inverse.
Inverse. To sine of negative 1.
Sine to the negative 1 on your calculator.
0.9623. So why would you do that?
To find out what the angle C is.
I would have just put 0.9623.
But that's not the angle, that's the value of sine C. Remember those inverse functions, and when you put that sine inverse next to that sine, it cancels out, so you have to apply sine inverse to both sides?
You say it one more time, why is it we didn't find the inverse?
To find the angle. All this gives us is sine C is 0.9623. How do I find C?
But you don't have to do that in the other ones, right? Only in this case.
Huh? In what case?
Because when we were finding it right here, we didn't have to do that. 13.31 or...
Right, because we were given two angles. We're in a whole different case. We're in a different case. This is how I get rid of that sine, and I'm just left with C. Remember? And now I have this, which she said was what? I can't remember. 74.21. Okay? That's how we get to the angle C. Now, I have two triangles, though, right? I have two triangles. So I can call this C1, and I have a C2 out there. Because I said that what? Sine is positive in the first quadrant and the second quadrant, right? This is a first quadrant angle. How do I get to my second quadrant angle? What do I do? How do I get to my second quadrant angle that has that same value also? Subtract it from what? Okay. And why do we do that? A complete triangle? What? Yes. Yes. Second quadrant stops at 180, huh?
Why have we got two C's now?
Because going through all this put us in this situation here where we had this inequality that held true. Okay? Because A was acute, it was going to be 1 to 3. This didn't hold up, this didn't hold up, this held up. Which, you know, there are two angles that have sine value of 0.96. Just like there are two sine angles, and let's just go out of this problem for a minute. What two angles have the value sine square root 2 over 2? Look on that unit circle. What two angles have sine positive square root of 2 over 2? What are they? Sine one's in the first and one's in the second one. Which one?
Over 4 and 3/4.
Two angles. So when we have this sine being positive here, that means there are two angles where that will have that exact sine value. We need to find those two angles. In the other situations, though, when we have one possible triangle, then it'll be a little different. We don't have to worry about it. But by us doing this little work here and we're in this situation, we need to find those two angles.
I know what you're saying now. So that is, so we have to find all, what we're doing on this problem is finding everything we can possibly find.
Right, but we have two triangles that we have to solve for. The big A, and little b will be the same for both triangles. What will change, and little c, little c will be the same. What will change will be big C, little b, and big B. So we have two situations. We have this situation where we got 74.21, and the other situation we do what? 180 minus that 74.21, which gives us 105.79 degrees. And these are my two situations. So now for both of these situations, I need to find what? Little b and big B. Is it making sense to us now, hopefully?
Since they're saying that there's two possible angles, that's why you have to find two?
Yes.
Okay.
Yes.
I thought you would subtract, go back to the original A and subtract that also.
No. Just for C. Just for C here.
Oh.
Because that's what we're finding is C. This is what we got on our calculator. But knowing there are two, we need to do 180 degrees minus C1. So, well, no, our big A, and little c will remain the same for both triangles. The big C, the little b, and the big B will change. Okay?
Now is there two A's and two B's and two C's?
No.
If there's two triangles, then wouldn't there be?
A, what you're given will remain the same in the problem.
For both the triangles?
For both the triangles.
Okay.
So there are two triangles with a 60-degree A, a 90-degree A.
Yes, yes. And let's break this down even further into triangle number 1. Okay? Triangle number 1 will be the case where C1 is 74.21 degrees. So we have a triangle where A, B, C, little a, little b, and little c. This is 60 degrees, little a is 9. For this triangle will be 74.21 degrees, little c is 10. So we define big B and little b for this specific case for the first triangle, okay? Using this as C, okay? So let's find big B. We can find big B because we're given what? Both the angles is minus 74.21 degrees, minus 60 degrees. So big B would be what? 45.79 degrees. Okay? And what is little b? Well, I need to go back to my law of sines here, okay? And I'm given my A, so let me say that this is going to be what? I can multiply by sine B, and I have what? A over little sine A. Now, y'all are going to have to get the mode down of being able to configure these formulas to what you need to be. We really don't have time to teach how to get these formulas the way that they should be. So you're going to have to go home and review that, okay? But it's a matter of going back to that formula and multiplying something on both sides, okay? So we have sine of B, this 45.79 degrees, times A, which is 9, over sine A, which is sine 60 degrees. And when we do all that, we get 7.45. Okay? This is triangle number 1. Triangle number 1. Okay? And I promise you, law of cosines doesn't have all this. Okay? This is going to be the hardest part here, this ambiguous case of law of sines. Okay? Triangle number 2. Now, we have that C2 is what? 105.79 degrees. The same thing, but now what? We're using a different C2, a different C. So our angle B is going to now be 180 minus 105.79 minus 60 degrees. So our big B is what? 14.21 degrees. Notice that it is relatively smaller than the B we found in the first one. And little b, sine formula, sine big B, which is now 14.21 degrees, times A, which is 9, over sine 60 degrees, and this gives me 2.55. Okay? 2 triangles.
So both of them are final.
All this stuff. Final answer, this is triangle number 2. For triangle number 3, triangle number 1. So the circle, because we have 2 situations. This is what I found for triangle number 1, triangle number 2. Question in the back, yes.
Okay, so on the I just out of curiosity, normally you set up like the bottom part where it's B with sine 14.21, and then we do it over A. Why would we not do it over C?
You can do it over C, but you want to do it over A because that's given. We've approximated C.
Okay.
And we will have approximated twice if we do that. I'm not saying it is wrong. I'm saying that you would get a more accurate answer because A was given. And it wasn't approximate, it was given as an exact thing. But you can use C, you just may be off by a decimal place or so, and that much to me isn't gonna matter. To me, you know, because I did mine, I got what, 74.21? You said 74.22. I wouldn't count that wrong, okay? But round to that second decimal place somewhere, okay? Yes?
Why did we find the sine of C? And we got two angles. Why couldn't we find, like...
No, right here we only had one angle. We only had angle A. And because we were given side C, we didn't have any information about B, so we had to find the angle C here. And I know, this is a lot to digest. I realize that. We want to... You think so? Oh, okay. See, what I think may be hard for you, you say it's easy.
Well, because I thought geometry was better than algebra.
I can't judge, so I don't even try anymore. I don't try anymore. Okay, y'all, another example. Suppose we're given, okay, here we're going to go back to degrees and minutes. 2 degrees, 4 minutes. Little b is 6.2, and little c is 5.8. So y'all, I said that we wouldn't do much with degrees, minutes, and seconds. Well, we're going to do a little bit with this degree stuff today. Okay?
But how do the minutes relate to the angle measurement?
They account for the decimal part or the fractional part of the angle. Like 74.21 degrees, we could change that 0.21 degrees to minutes. And as a matter of fact, we're going to change this to a decimal form so that we can work with it.
So that's like saying length and time. Because the minutes, the time in 2 degrees is like a measurement. So how is that related?
No. What, okay, you can relate it to time. In time, we have days, hours, minutes, seconds. Okay? Degrees, right, well, that's a measure of something though, isn't it? That measures how, we can measure how many seconds are in one day, how many minutes, how many hours. The degree portion, that fraction, that 0.21%, you can measure. I can get 74, I can change that instead of degrees. I can figure out how many minutes 74 degrees is. So it's just a way of converting. Just a different way of converting.
What about, would that be, that be 2.75?
Yes, it does. How do we know that? Because we end up dividing that 45 by what? 60, right? Y'all remember we did a little bit of this a long time ago, didn't we? How do we translate this? Well, B, 2 degrees, 45 minutes over 60. What's 45 divided by 60? 0.7, it should be 0.75 or 75, and that tells me what my decimal approximation is. So that's 2.75 degrees, the same as 2 degrees 45 minutes. Okay? Now, let's go outside this situation here, because now I need to say that A is just 2.75 degrees, little a is 6.2, and little b is 5.8. Why am I doing that? Because that's how they say it in this example. Big A and little a are given. So they're giving me over here big B and little b. I need to label that big A and little a. And this other one that's odd, that's out, is B. And I only use this to determine which situation I'm in. So is A obtuse or acute? Definitely acute. Now, which situation am I in? I might need to figure out, do I need to figure out H? Well, not really, because A is greater than B, isn't it? Which means I'm in what? This situation. I need to figure out H, and I could figure out H, but because A is definitely bigger than B, then there is only one triangle. Yay, and it simplifies everything because there's only one. So do we see how there's only one triangle here? Yes, no? Yes. Okay. So there is only one triangle. So we only relabel that stuff so that we can see how many triangles we have, and then we come back to this problem. And let's go about figuring out the rest of this stuff. So we do change the variables. We change them what? Outside the problem to figure out how many triangles we need to find. And then we come back to the problem and we deal with the variables that are given. Does that make sense? Hopefully. Okay. So now I have big B, little b, and C, which means I can find what? Big C. Right? I can find big C. Sine of big C is little c times sine of big B over little b. Put my components in, 5.8, sine of 2.75 degrees all over little b. Now, if you have those calculators, if you have a scientific calculator, your calculator should have degree, minutes, and seconds mode. And if you figure out how to do that, you wouldn't even have to convert because it will probably give you your answer back in degree, seconds mode. Now, if you don't have that, or if you don't know how to use it, then you need to translate it into just degrees, okay? But if you know how to use your calculator with that degree, second mode stuff, you don't have to translate a thing. So you may want to do that. So what this means is that, what? What is all this stuff? I didn't get that. What is, anybody get all that? What's that number? Okay, speak up. 0 point what? Wait. Point what? 0 point. Say that again. 0.449. That's what you said. Okay. And if we do the inverse sine of both sides, C will be approximately equal to 2.57 degrees. Okay? And since we have one triangle, this is the C we're going to use, okay? One triangle. Now, we can go ahead if we want to and change this back to degree second mode. I have my what? 0.57 now times what? 60. Because the answers will probably, if they give you answers in degrees and seconds, then they want you to get your ultimate answer. If they give you a problem that has degrees and seconds, then they're going to give you answers in degrees and seconds. So this is 2 degrees and 34 seconds. So you may have to round your seconds. Okay? Up here we divide it to get it to this form. Down here we multiply by 60 to get it back to that form. Okay? No. We found big C. Now we need to find what? Big A. We can find big A. Big A is 180 minus this 2.757 degrees minus this what? 2.75 degrees. So A is 174.68 degrees. Now, how do I change this thing? Same way. 174 plus what? 68 times 60.
You gotta put it back in minutes.
You know what? I would accept it if you didn't. But if you're doing practice problems and as far as practice problems, if they give you this, then their answers are all going to be in there. On a test, I would accept decimals, okay? Because that's a whole lot easier to work with. Okay? So we need to find little a. Little a is what? Sine big A, and we'll do decimal, over what? Sine big B times little b. 11.98. Okay? So yeah, I would accept, I would definitely accept it in a decimal form, you know. I would. I don't really like dealing with degrees, minutes, and seconds, but there are so many practice problems where they do that, so I felt we need to do some here. So many contain this degree, minutes, seconds. So you may have to go back to where we talked about it in the first unit. Okay? You may have to go back there, but they are really in there a whole lot. Okay. So we've done what we've had, what, 2 triangles, 1 triangle. How about no possible triangles? What is that situation going to look like? Well, suppose now A is 85 degrees, little a is 15, and little b is 25. So here A again is acute. A is smaller than B, which means I need to find H. And here, this example, my letters are all labeled like they should be labeled according to our definition, right? Big A, little b. So H is what? Little b times sine of big A. So H is what? 25.10. That's H. So here, my A is less than my H, isn't it? Which means I have what? No possible triangle. Yes.
Where does the H go on the triangle?
I erased it. It's height. Like if we have something like this, you drop this vertical, forms a 90-degree angle, that's height. Now, what if I just started working this problem? Or what if we said to verify that there are no possible triangles? Huh? Oh, it's not going to be that bad. If we verify, if we go out here and we try to find big B, okay, let's try to find big B. Sine of big B is little b times sine A over A. Then, if we do all this, we get that sine big B is 1.66. What do we know about the range of the sine function, class? It's between what? No. -1 and 1, right? Just plain old f of x equals sine x goes up to negative, down to -1, and it's high up as 1, dealing with amplitude. This is bigger than 1, which is outside the range. That's how you so we verified it. There is no angle that has sine value 1.66 because what? The range. That's not in the range of the function. So there are no possible triangles.
So how do we know that? Like the range?
You're supposed to know it. You're supposed to know that the range of the sine function and cosine and secant and all that. No, not secant, just sine and cosine, -1 to 1. Y'all missed that? No, you didn't. When you were graphing this stuff, what happened? Amplitude 1, amplitude negative, Y'all remember that? I'm sure I said it. And we had to talk about range, domain, and range a whole lot, dealing with arc cosine and arc sine. Y'all are having a mental lapse on me today. Yes, sir.
You said outside the range, what makes there be even correlated to the range of the problem? What A is 15, what makes you say that since,
Because if you're just dealing with plain old sine x, any value you put in, you should get something out between -1 and 1. And we get something out bigger than 1. And this is for plain old sine x. I promise you, if you sit there calculating all day long and just do sine x and put in any x, you're going to get a number between -1 and 1 all the time. All the time. Because the domain of sine are all real numbers.
on every problem, we don't have any constant triangle with verify?
Oh, I don't know.
Or you just did that for everyone?
I did it because you need to see it. Okay, y'all, we got one more little thing to cover there. We're not going to get to log cosines, oh well. But we ain't talking about the area of an oblique triangle. Remember, these triangles we're talking about today are oblique. So let's talk about the area of an oblique triangle.
You have to find the area, you probably have to find all the angles and sides and then multiply them together.
No, you don't need all the information. You just need a few components of it. So, area of an oblique what's the area of just a triangle? It's 1/2 base times height, right? Well, these problems you may not be given height. You can find height, but you may not be given height. The area is, and we have several forms depending upon what you're given. It's 1/2 B C sine A, and this is if you're given A, big A, little b, little c, or it's 1/2 A B sine C, or it's 1/2 AC sine B. Depends on what you're given. Let's note some things about these formulas. Notice the angle that you're given, you're using the other two sides, okay? Sine of angle A, you multiply by BC. Sine of angle C, you multiply by AB. Sine of big B, multiply by AC, okay? So, one example. Suppose we're given that big B is 130 degrees, little a is 62, and little c is 20. Then what's my area? Because I'm given B and I'm given the size of the other two, it is 1/2 what? 62 times 20 times sine 130 degrees, which is 474.95. Okay? So they're going to give you the values of these sides and angles such that you can use one of these formulas. It's not going to be that you're going to have to find anything, okay? It's going to be given, okay? All right. Are there any questions about what we have done today? Next week will be a little easier. Law of cosines, not this in depth. Okay? As a matter of fact, and it's not going to take as long as this took. We'll start in on some other things on the day of that lesson. Any questions about anything? Okay. No questions. Then we will, end this class for today.